Today we're going to be talking about models of parent functions. You should have the worksheet that is titled Models of Parent Functions. We watched a video on YouTube the other day about parent functions. Now, can anybody tell me what was the one characteristic they all had in common? That's correct. They all start at the origin. Now, you're going to see today that there are a few that don't start at the origin, and we'll discuss those as well. So, as far as the worksheet goes, you should have the category, the equation, and the graph of all parent functions. What I'm going to ask you to do is make sure you know how to graph the parent function, what the equation is, and also what graph the title is that goes with the graph that I'm going to give you on your quiz. You guys will have a quiz over this worksheet. The one thing we are going to add to this worksheet today is going to be the domain and range. So let's get started. The first equation is my linear. Most of you are familiar with this. For my domain and range, my domain for the linear parent function is going to be all real numbers. And my range will be the same. If you notice the graph, it uses both x and y values, and they are both positive and negative. That graph is continuous because it's going to go on forever. You may also write negative infinity to positive infinity. It's the same thing for the domain and range. So now let's look at quadratic. Remember, Q goes with U. So if Q goes with U, my shape for a quadratic is a U shape. My equation is y equals x squared. Most of you are familiar with this one as well. Linear and quadratic are the two most common parent functions that are used. So my domain and range for this particular function, domain is all real numbers, and my range will be y is greater than or equal to 0. If you noticed, we do not actually go below the x-axis. So my graph will be greater than 0 for my range. The next one is square root function. You guys should be familiar with the square root symbol. For my domain and range, my domain, x is greater than or equal to 0. And for my range, my y is greater than or equal to 0. Again, if you notice, this graph only stays in quadrant 1. So I'm only using positive numbers for both the x and the y. The next one is the rational function. My rational function, my domain, here I have all real numbers. But what do you notice about the rational function that was different from my first three? That's correct. It does not go through the origin. So the way I'm going to write this, it's still all real numbers. I just have to make sure that I put except that x cannot be 0. And it's going to be the same thing for my range. My range is also all real numbers, except that y cannot be 0. And by using y equals 0 and putting a slash through the equals, that's what it means. It will not equal 0. So I can use every number in the number line except for 0. Okay, let's flip to the next page. We have 3 more parent functions. Now these back 3, or excuse me, the exponential, logarithmic, and the rational function we will get to later in the year. But I definitely want to make sure you understand the linear, quadratic, and absolute value. So let's actually skip down to absolute value. When I talk about absolute value, I want you to remember V for value. Okay, my shape of the graph is going to be a V. So what do you notice about the V? My domain, all real numbers. Now what about the range? Am I using both positive and negative numbers? No, so I'm going to write y is greater than or equal to 0. Again, this graph goes through the origin. My origin is 0, 0. Okay, now let's pop back up to exponential. My exponential graph, if you notice there are 2 different sections for exponential. All this tells you is whenever I give you an example for exponential, if the b is bigger than 1, my graph will look like this. And if my b is a decimal or a fraction, so in between 0 and 1, then my graph will look like this. So for example, if I have the equation y equals 2 to the x power, my graph would read left to right. For example, down here, if I had y equals 1/2 to the x power, then my graph would read going down. Okay, so be careful because you might get one or the other. So make sure you know which direction the exponential graph is going to go. So let's talk about the domain and range. And this will go for both graphs. My domain, I have all real numbers. And now what do you notice about the exponential graph? Do I go through the origin? No, I do not. So again, I have to make sure I write except that x does not equal 0. Now what do I notice about my range? My range, I'm using all positive numbers, but can I go through 0? No, so I can actually write the range as y is greater than 0. By not putting the equal to sign, I'm not using 0. And then the last one we're going to talk about is the logarithmic function. Here, my domain is x is greater than 0, and my range, all real numbers, except here, once again, y cannot equal 0. So if I notice this graph gets as close as it possibly can to the y-axis without actually ever crossing over it or touching it. So what I want you guys to do, make sure you have the domain and range written for every function. Please study this. You need to know what the graphs look like. You need to know the names of each parent function, and you need to know the equation. So again, I will give you a quiz over this probably sometime in the next week or two. So if you have any questions, please let me know. Enjoy your weekend.